Yeah, so after all that graphing in section 3, we have one more curve to look at that's important to us in our study of the calculus, and it's called the Rose curve, and let's spend some time with this one too. So they have the following form, and what makes them unique is that there's a multiplier right there in the argument of your trig function. As an example, we could take a peek at maybe r is equal to 3 cosine 2 theta, maybe, okay? And it makes a difference whether it's even or odd, by the way, the multiplier itself. I've chosen an even number 2. Let's see what happens, okay? So this time to explain it, I really will lean on this Stewart, so to speak, method of graphing. So if we were to graph r is equal to 3 cosine 2 theta, we're going to start up at 3 and descend to negative 3, and the curve itself would do something like this, and it goes, did you know that it goes around twice? It's because of the multiplier 2 by the time you get to 2 pi. That's a lousy picture, but that's what I'm trying to envision here. So this is pi when it reaches, the lower part is pi over 2. This guy over here, I think, is 3 pi over 2. In between, these are important too, pi over 4. And I think if you go by fractions, this is 3 pi over 4 and 5 pi over 4 here. And finally, 7 pi over 4. And it makes a difference because you start off positive, and then this is a positive region, and so is this one. But you also have the negative regions for r. So you know what that means when r is negative, you go in the opposite direction. So this is kind of a cool thing to graph because, well, watch what happens. You start off, the curve starts off, in fact, I'll do the negatives and positives in blue and red so you can see it better. So you start off when theta is 0, you're at 3, okay? But by the time you reach pi over 4, which is this angle here, imagine theta turning in this direction, your curve bends towards 0. That's a terrible curve, and we'll do better. Oopsie, we don't want to wipe out our axis either. So looks something like this. Okay, like that. So theta is scoping this out, like so. But then you go through this whole negative swoop. And by the time you get to pi over 2, which is up here, you're actually pointing in the opposite direction down here, and r is negative 3. So even though theta is turning in that direction, the curve grows and grows and grows in strength till it reaches negative 3. Okay? Then you reach 0 by the time you get to 3 pi over 4. So if you mark out 3 pi over 4, what happens is you're swinging in this direction and you get less negative until you reach 0, like that, okay? Do you see what's happening is we're starting to sketch out these petals, if you will, these lobes. We're going to go positive now. We're going positive again, this time 3 pi over 4 to pi. It's going to go more and more positive and reach 3 here. And then it's going to shrink down to 0 at 5 pi over 4. So I'm going back and forth between looking what's happening here on the right and then then sketching on the left. Going to go back down to 0. Okay. Guess what? I'm going to go a negative again. It's going to go negative at 3 pi over 2 down here. So we've journeyed here, and now we're going in this direction, and we're going to go to a negative 3 by the time we reach it. So look what we got. This is negative 3. It's going to go to 0 by the time you get to 7 pi over 4. Are you following? As we go this way, it shrinks to 0 and finally turns positive one more time. And it turns positive from 7 pi over 4 to 2 pi, and it finishes its journey. And it's a rose curve. It's actually, I'd call it a daisy curve, but they call it a rose curve. And so if you follow the bouncing ball, and I'm just going to do this one time in green, it starts off here and it cruises this way and then down and back up and then around to the left and back to 0, and then on up through negatives and back down, and it finishes its loop. By the time it gets to 2 pi, you've done the entire curve. And it's got 4 petals. Now that's the thing. If, let's say, B is even, and we're talking about a format like this, the B is the multiplier inside, then there are twice B petals. Talking about 1, 2, 3, and 4 petals all the way around. Okay, that's good to know. That's a good thing to see or know when you're graphing these guys. Of course, if it's an odd number, okay, we'll do an example of that really fast, I think. We'll see. You get something different. So that's a thing to remember. And let's do this, guy. So let's say we do a sine this time. And if you want, we can, okay, let's do it. R is equal to, say, -2 sine maybe 3 theta. So now we put an odd number in there, and we put a negative in front for spice. But I'm going to do the Stewart method again, theta and R, and I'm going to graph this guy for sine is equal to, R is equal to -2 sine 3 theta. Now that guy, let me do this from trig where you go 0 and you got is less than or equal to 3. Well, that doesn't help me much. What does it do from 0 to 2 pi is really the question, okay? All right, so it's going to start, let's say, at 0, at the origin. It's going to cruise down and back up again and down, and its amplitude is 2, right? Okay, when does it get done? Okay, does one full circle when 3 theta is equal to 2 pi, or you get done at 2 pi over 3, okay? 4 pi over 3, 6 pi over 3. So actually my picture, if I can get rid of this curve, I'm going to really smush it in, because that's what it's doing. The amplitude is, I mean, the period or phase, the period. 2 and 3. It finishes 3 periods or wavelengths by the time you get to 2 pi is what's interesting about it. And of course it's got positives. And it also has the negatives going on here as well. So you got the negative here and here and here and here. Okay. So what does that look when you graph the thing? I think we're in for some surprise, a little bit of a surprise here too. So we start off this way, and I think I'll do this. I'll do it in the code again, right? We start at 0. By the time we reach, oh my goodness, we got to figure this stuff out. So we said that this was 2 pi over 3. This is 3 pi, or this is 4 pi over 3. So in between is pi over 3. And this is going to be, let's see, 3 pi over 3. So this is pi, and then 4, and then 5 pi over 3 is where, this is where the crossings are, and then 2 pi. But we're also interested in this, guys, so this must be pi over 6, right? And that'd be 2, this is 3 pi over 6, or pi over 2. 4, 5 pi over 6. Is this worth it? Yeah, it is. 5 pi, what is it, 5, 6, 7 pi over 6. 8, 9 pi over 6, which is 3 pi over 2. 10, 11 pi over 6 up here, finally. And then 8 pi over 6, 12 pi over 6, we're done. So we'll go to red, and we'll loop. By the time we get to pi over 6, which is this guy, we're actually pointing in the opposite direction 2 units. So we're actually 30 degrees this way. That's supposed to be 30 degrees. So we're at -2 here. Then that's what happens when you swing this far, is you're going to go actually this lobe. Okay, and it's kind of skinny, actually. It should be fuller than that, but okay. Then by the time you get to pi over 3, you're finished. You're back to 0. All right, now I'm going to switch to blue, because now we're positive. By the time we get to pi over 2, which is here, we've made it up to 2, positive. And then it drifts down to 0 by the time you get to 2 pi over 3, which is here. You getting sick of this? We're almost done, actually. Watch. Okay, then you go through negatives. You go through the negatives. By the time you get to 5 pi over 6, which is here, you're actually pointing in this direction, negative 2. Okay, and then 5 pi over 6 getting to pi over here. By the time you get to pi, you're back to 0. Okay, boy, boy, these lobes are looking pretty sad. Let's try to improve it a little bit. He's a little bit longer. They seem to be growing. Okay, something like that. The first one is a little too weird looking. So I'm at pi, okay? And then after we get to pi, we go through positives. And so by the time we get to 7 pi over 6, which is this direction, okay, we're actually swinging through this guy again and back. So to cut to the chase on this one, we started, where did we start? We started here, we cruised here, it was negative, then it's positive, and then it's negative, and then we're not even done, that's to pi. Then we're going to go through this guy, positive, and now negative when you get to 3 pi over 2. It's negative, you can see it right there. And then it goes to 0. Then you swing through these guys, you're going to get positive, and then 0. And then finally you finish, well, I think you finish right there. What happens is, when it's odd, for some reason, right, because of the geometry and the trig, you swing through the pedals twice. Okay, so let's write a note. If B is odd, then there are B pedals. And as theta goes from 0 to 2 pi, the pedals are the curve swings through the pedals twice. And that's about all I have to say about rose curves. They're interesting. If you compare the two, look at this. If theta is 2, you have 4 petals. If theta is 3, you have 3 petals twice. Okay, and that's it. Now we can do some calculus. I'll see you at the next one.